11.9. So we're still talking about power series representations. So remember, our whole focus right now is I want to take a function and I want to write it as a power series. Okay, and we did some last time, but I want to do some different functions than the ones we saw last time. So let's do natural log. Let's say I want to find a power series representation for the function ln of 1 plus x and its radius of convergence. So a lot of the examples we looked at last time, they had to be something I could write as 1 over 1 minus something. ln is definitely not like that. But we ended class last time talking about derivatives and integrals. So maybe we want to take this function and do one of these things. I either want to take its derivative or I want to integrate. We have natural log. It's a lot easier for us to take the derivative than to integrate. So let's take the derivative of that. Okay, I'm going to call this f of x natural log of 1 plus x. And what's the derivative of f? What's the derivative of a natural log of x? 1 over x, so I just got to use the chain rule. 1 over 1 plus x. And then multiply by the derivative of the inside, which is just 1. That looks like 1 over 1 minus, right? Almost. What do I need to change? I don't have a minus here, and I need to have a minus if I'm going to use my formula. So I'm going to replace that plus x with minus a negative x, and now I can use my formula. It's the sum from n equals 0 to infinity, and then whatever's in parentheses here, so I have negative x, it'll be negative x to the n. So if you wanted to write out some of the terms, you could here. You would have 1 minus x plus x squared minus x cubed, and so forth. It's alternating.
Does it have to start at 1?
The formula that we're using starts off at n equals 0.
Okay.
The reason why also it starts off at 1, we're looking at a geometric series, and the sum formula, what's in the numerator is a, and that's the first term in your series. So my first term is 1 here. All right, so I've got a power series representation, but I don't have it for f of x, I have it for f prime of x. Right? So if I know what f prime is, I can get back to the function f just by integrating. Okay, so if I want to get ln 1 plus x, this is my f of x, I need to integrate 1 over 1 minus x. This is f prime of x, we're integrating here, dx.
Shouldn't that be 1 plus x?
1 plus x, thank you. Yep, 1 plus x. And then, well, here's the part where we're going to use our result of the end of class last time. I'm going to replace this function 1 over 1 plus x with this power series, and if I want to integrate, I just have to integrate each one of these terms here. So I'm going to replace this by 1 minus x plus x squared minus x cubed, and so forth. And then I just integrate term by term. So I'm getting x So don't forget the plus c. I like to write it at the beginning, a big C. And then integrate 1, x minus x squared over 2 plus x squared over 3 minus x to the 4th over 4, and so forth. So this is C plus, and then all of this stuff here we can write as a series with a summation notation. The sum, let's see, it's x to the n over n. Maybe I'll start it off at 0 like the other one. N plus 1 over n plus 1, negative 1. The first term is positive, so it's n. It's either n or n minus 1. Okay. So I think this is the first example we've done where we've had to integrate to get these, to get the power series representation. There's one catch. When you integrate any kind of function, you always get plus c. You always get this plus c when you integrate. But this is equal to a function. So I should be able to find this value of c. So before I find that value of c, let's talk about our radius of convergence real fast, because that's going to play a role. Let's go back up. We use this formula here. So let's talk about what our radius of convergence is. My r is this thing I've underlined, this negative x. And so I know that that converges when the absolute value of negative x, or r, is less than 1. And I can just get rid of that negative because it's inside of the absolute value. So it looks like my radius of convergence is 1. And my, if you want to know the interval of convergence, it's between negative 1 and 1. So I need to find this c. And the way I'm going to do that is I'm going to plug in a number for x. Okay? I'm going to plug in a number for x, but it can't be any old number. It should be inside of your interval of convergence. Okay? So you can choose any number you want inside your interval of convergence, and ideally you want to pick the easiest number you can to plug in. So the easiest thing I can plug in between negative 1 and 1, say 0. 0. So you're going to plug in, let x equal 0, and you're going to get ln of 1 equals c plus let me move that up. Well, I have 0 to a power, which is just 0, times a number, that's just 0, divided by a number, that's still 0. So this whole thing here, all of these terms become 0, and I add up 0 forever and ever, the whole thing becomes 0. So you're left with just c on the right-hand side. But ln of 1 is just 0. So actually, there is no constant. So my power series representation for ln of 1 plus x, it's just the summation part, because we have no c. It was n equals 0, n x to the n plus 1 over n plus 1. So this is your power series representation. And we found the radius of convergence earlier. So if you integrate, there is this extra step where you have to solve for the constant. In this case, c happened to be 0, but that doesn't have to work out every time.